In this video, I am going to explain the concept of Nyquist plot in detail. First of all, let us see what is meant by Nyquist plot. Nyquist plot is a plot which is drawn in f of s plane or g of s into h of s plane corresponding to the Nyquist contour which is in s plane. So Nyquist plot is a plot that is drawn in f of s or g of s into h of s plane corresponding to the Nyquist contour which is in s plane. And here we see Nyquist contour. What is meant by Nyquist contour? Let us see what is meant by Nyquist contour. Nyquist contour is a contour or it is a shape that encloses the entire right half of S plane to investigate the presence of poles of G of S into H of S on the right half of the S plane. To draw a Nyquist plot, one should have a knowledge of stability criterion and drawing a polar plot. So as we know that if there is an S plane here, for example, let us see, there is an S plane here. S plane has two axes. One is real axis and imaginary axis. Real axis is represented by sigma and imaginary axis is represented by j omega. If the poles of open loop transfer function lies on left half of the S plane, for example, here, if we consider any open loop transfer function, okay, the poles of open loop transfer function lies on, okay, left half of the S plane, then the system is stable system. If the poles of any open loop transfer function of the system are lying on right half of the S plane, then the system is unstable. If the poles of an open loop transfer function lies on purely an imaginary axis, then the system is marginally stable. So this stability is defined for open loop control system. Okay, this stability is defined for open loop control system, right? But whereas for a closed loop control system, or we can also find out and determine the stability of the system. So as we know that transfer function of a closed loop control system can be written like this: C of s is equal to g of s divided by 1 plus g of s into h of s. In order to obtain the poles of this closed loop transfer function, we have to equate this denominator polynomial equal to 0. That is 1 plus g of s into h of s equal to 0. Then here g of s into h of s is equal to -1. Right? So here g of s into h of s equal to -1. So this g of s and h of s is nothing but f of s plane, or we can call it as g of s into h of s plane. Here, as we have seen in Nyquist plot, it is a plot that is drawn in f of s or g of s into h of s plane corresponding to the Nyquist contour which is in s plane. So here we see that g of s and h of s. So here we need to have a plane of g of s and h of s, right? So when we draw a plot in this g of s into h of s plane corresponding to the Nyquist contour that is in s plane, then that is known as Nyquist plot. Okay, so that is why here we need to take another plane. Okay, so here real axis is represented by letter u and imaginary axis represented by letter jv. So this is nothing but f of s plane. This is complex variable s, which is equal to sigma plus j omega. So corresponding to the s, we can write a function of s, which is known as f of s, is equal to u plus jv. Okay, so this is a complex variable, and this is nothing but complex quantity. Okay, so here, what is meant by Nyquist plot? Nyquist plot is a plot that is drawn in f of s or g of s into h of s plane, corresponding to the Nyquist contour, which is in s plane. So that means here we need to take a contour on s plane here. Okay, so what I said, in order to find out the stability, or in order to determine the stability of the open loop control system, we have seen the analysis on S plane. And whereas if we want to find out the stability of the closed loop control system, we have to see an analysis on f of s plane. So that is why here we can consider it for closed loop control system. Okay, closed loop control system. Now let us see what is meant by Nyquist contour. Generally, contour is nothing but a shape that encloses the entire right half of the S-plane to investigate the presence of poles of G of S into H of S on the right half of the S-plane. Okay, so that is why here there is S-plane. We need to consider a contour that encloses the entire right half of S-plane. See here, there is an entire right half of S-plane. It has to be enclosed by a contour or a shape. Why this shape has to be considered onto the right half of the S-plane? In order to investigate the presence of the poles of G of S into H of S or F of S on the right half of the S-plane. So when we investigate the presence of poles on right half of the S-plane of G of S into H of S or F of S plane, then we can determine the stability of the closed loop control system. Okay, so that is why we need to consider a contour in S plane, so that we can map a plot in f of s plane. So we need to take a contour on S plane. So corresponding to this contour, we need to map another contour on f of s plane, which is known as Nyquist plot. So let us take a contour on S plane. This is nothing but a contour, which is known as Nyquist contour in S plane. See here, there are three sections in this contour. This is one section, and this arc is another section, and this one is another section. This section is represented by a letter called as C1, which is varied from 0 to infinity. And another section, here see, from this point, this is in the shape of arc. This arc is considered to be another section C2. So this is another section C2. So this is entirely section C2. Okay, and here from this point towards origin, so there is another section known as C3. Totally three sections are there. This is one section which is along C1, varying from 0 to infinity, and this is another section C2, which is varying from plus 90 to minus 90. That means plus pi by 2 to minus pi by 2. So as we know that in polar plot, positive angles are taken in anti-clockwise direction. Suppose if it is 0 degrees and it is 90 degrees, which is equal to 90 degrees, and it is okay, plus 180 degrees. Okay, and here it is plus 270 degrees, and again here it is 360 degrees. The negative angles are taken in clockwise direction. Here it is minus pi by 2, which is equal to minus 90 degrees. Okay, and here minus 180 degrees, and here it is minus 270 degrees, and here minus 360 degrees. This is how we take angles, okay, on polar graph. So here when we consider this section C2, it is varying. That means the angle of the section C2 is varying. The angle of the section C2 is represented by letter theta. So it is varying from plus pi by 2 to minus pi by 2. And section C3, it is varying from minus infinity side to omega equal to 0 side. Sometimes, this Nyquist contour is different. Let us see that one also. So when pole is located at origin, at this particular pole, the Nyquist contour shape is like this. Suppose if there are some more poles on imaginary axis like this, okay. So this section C1 gets changed to another section like this. Here also at this particular area, this is another section. Wherever the pole is located on imaginary axis of S-plane, there the Nyquist contour not continued, but it is detour. So here also at this particular pole, it is detour. And here also, it is also detour. So that is why if there are n number of poles on imaginary axis, that many number of detours may happen on Nyquist contour. Now come to this diagram. Here, there is a radius of this arc, that is section C2. That radius is represented by letter capital R. Okay, capital R. This is capital R. According to the polar plot concept, this radius is the magnitude of the transfer function, and it has some certain phase angle also. That phase is represented by e to the power of j theta. Okay, so this is the magnitude. R is the magnitude. E to the power of j theta is the phase of this, okay, particular section. So here C2 has radius r and phase, that is e to the power of j theta, and this r is tends towards infinity. Okay, this r is tends towards infinity. That means this radius is okay, tending towards infinity. But in this case, we can see another arc. Here in this figure, we have an arc which is section C2. Here also there is an arc which is section C2, and also there is another arc which is known as section C4. So for this arc also there is a radius. Okay, for this arc also there is a radius, but this radius is represented by a small letter. Okay, this radius is represented by small letter. That is why we can write like this. So r e to the power of j theta when r tends to 0. That means, this r is the radius of this section C4 is towards 0, but the radius of the section C2 is towards infinity. So here there are four sections. Section number C1. Section number C1 is varying from omega equal to 0 to, okay, omega equal to infinity. And section number C2 is varying from plus pi by 2 to, it is ending at this particular point. That means this is minus pi by 2. Okay. And section number C3 is varying from omega equal to minus infinity to here omega equal to 0. We can see the radius of this section 2 like this. That is r into e to the power of j theta when r tends to infinity. Okay. In this S-plane, we can see that there is a Nyquist contour. The entire right half of the S-plane is enclosed by this Nyquist contour. That means the poles or zeros, or the combination of both poles and zeros that are located in the right side of the S-plane are enclosed by this Nyquist contour. Suppose if only poles are located, okay, in the right half of the S-plane, then in that case, what is the corresponding contour in f of S-plane, which is known as Nyquist plot? Similarly, if there are only zeros located in the right half of the S-plane that are enclosed by this Nyquist contour, then what is the corresponding contour in f of s plane, which is known as Nyquist plot? So Nyquist plot is nothing but encirclement of origin. Encirclement of origin. Now let us see how the encirclement of origin happens in f of s plane, okay, or g of s into h of s plane, corresponding to this Nyquist contour that encloses the number of poles and zeros that are located in the right half of the S plane. For example, if there are two zeros located in the right half of the S plane, these two zeros are enclosed by this Nyquist contour, which is directed in clockwise direction. So the corresponding Nyquist plot can be drawn like this. As I told you that Nyquist plot consists of encirclement of origins. See here, there are two zeros, and these two zeros are located on the right side of the S plane, and these two zeros are enclosed by this Nyquist contour. The corresponding contour can have two number of encirclement of origin. Okay, two number of encirclement of origin. That is, the circle may start here, and it may be directed in clockwise direction. Okay, understand? It may be directed in clockwise direction, and one circle is over and second circle is occurring here. See here, this is okay. It is started from here in clockwise direction. It complete one circle and there is another circle also. Okay, see here like this. The shape of this contour may be in any shape. There is no need to have any exact shape. Suppose if there are poles, okay. So if the poles are located in the right half of the S plane, the Nyquist contour, which is enclosing those poles, are directed in anti-clockwise direction. So corresponding encirclement of origin will also be okay in anti-clockwise direction. Got it or not? So likewise, there are 6 points that we have to understand from these two figures. We can conclude a point that if S-plane Nyquist contour encloses z number of zeros in the right half of the S-plane, then the corresponding contour in f of S plane will encircle the origin z times in clockwise direction. So similarly, we can say there are poles here. Okay, only two poles are there that are located in the right half of the S plane. Okay, so here the encirclement of origin happens in anti-clockwise direction. Similarly, if there are two poles located in the right half of the S plane, okay, then we can see like this. Okay, see here, if there are two poles, suppose here we have taken poles. Okay, this is one pole, this is another pole. These two poles are enclosed by this Nyquist contour in right of the S plane. So in this case, we can draw a Nyquist plot corresponding to this contour. So that is in anti-clockwise direction. That would be in anti-clockwise direction. That circle is started in anti-clockwise direction like this. Okay. This is in anti-clockwise direction. The origin encircled like this. Circle started here and closed. One circle is closed and continued. Another circle here it is. Okay. So in this case, if S-plane Nyquist contour encloses P number of poles in the right half of the S-plane, then the corresponding contour in f of S-plane will encircle the origin of f of S-plane P times in the anti-clockwise direction. Okay. We have to write here P times in the anti-clockwise direction. So do you understand the difference between these two? Okay. So in this way, there are some more points we can understand that if P is greater than Z and if P is less than Z, And if P is equal to Z, then what happens? Suppose if there are P number of poles and Z number of zeros located in the right half of the S plane, and P is greater than Z, and these both poles and zeros are enclosed by the Nyquist contour. In this case, the origin of the f of S plane encircled by P minus Z times, but in anti-clockwise direction. Similarly, both poles and zeros are encircled by Nyquist contour in S plane, but P is less than Z. In this case, the origin of f of S plane is encircled by Z minus P times. Z minus P times, but in clockwise direction. Okay. So here we have seen 4 points, and there are another two cases. That is, if P is equal to Z. If P is equal to Z, 0 times of encirclement of origin occurs. That means there is no any encirclement of the origin. This is fifth case. And sixth case is number of poles and zeros. Both these are not enclosed by the Nyquist contour. Okay. So in this case, the corresponding contour in f of S plane will not encircle the origin of f of S plane. That means there is no any encirclement in this case also. No encirclement. No encirclement of origin. Okay. So these are the 6 points that we need to remember in order to draw a Nyquist plot for any kind of problem in control systems.
ఈ వీడియో కానీ మీకు నచ్చినట్లయితే లైక్, కామెంట్, షేర్ చేయండి. మరిన్ని అప్డేట్స్ కోసం సబ్స్క్రైబ్ చేయండి.